Given the graph of y equals cos x, sketch the function g of x is negative cos 3x plus 1 on the domain negative pi to pi. The first thing I'm going to do is look at x is 0. We know that cos of 0 is 1, so this would be negative 1 add 1, which is 0. The period of the standard function is 2 pi, so with the 3x here, the period would be 2 pi on 3, which means it's going to be 0 here and 0 here. Now we know that cos of pi is negative 1. Indeed, we can see it on the curve that we have here. So 3x equals pi means that x is equal to pi by 3. So when x is pi by 3, cos will be negative 1. Negative 1 is 1, add 1 is 2. So it's going to be 2 here. And then we can see, because of the repetitive nature of the curve, that it's going to be 2 here, and it's going to be 2 here, and it's going to be 2 just here. Clearly then, it must cross its mean line at these points here, in between the max and the min. And then we know the shape of the curve, so it's going to go like this, come down to a minimum, and then come up to a maximum, come down to a minimum here, and then we just keep repeating. So it's got a maximum here, and a minimum here, and that would go up towards a maximum there. Given that y equals sine x is graphed on the set of axes below, sketch the function y equals cosec x on the domain 0 to 3 pi. So we know that there'll be an asymptote every time that sine is 0, because of course cosec x is 1 over sine x. You can't have the denominator equal to 0, so every time it is equal to 0, we're going to get an asymptote. Now the maximum of sine is 1. 1 divided by 1 is 1, so that must be the minimum of cosec. 1 divided by negative 1 is negative 1, so we're going to have intercepts here. And so what must happen is it comes down from the asymptote, takes its minimum value just here, and then goes off the top there. And then the same sort of thing here, and finally the same sort of thing just here.